Hello, good evening, everyone. Dear authors and invited guests, welcome to the technical session 4B. Myself, Aarti Mohan, and the session would be moderated by me. On behalf of Global Research Foundation, it's my great pleasure to welcome you all to the 9th International Congress on Information and Communication Technology ICICT 2024, London, UK. The 9th edition of the conference is being organized in a hybrid mode, and the virtual event is being held through Zoom today and tomorrow, that is 21st and 22nd February 2024. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 6 presentations. Will be given 12 minutes for the presentation and 2 minutes for the question and answer session round. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants to stay connected with us till the closing remarks. If you have any sort of query or update, you can write it to me in the chat box. Just before we get started, I would like you to introduce to the chairs of the session, Dr. Vijay Singh Rathore. Sir is a professor, CSE, and director outreach of Jaipur Engineering College and Research Center, India, and secretary, ACM Jaipur chapter, and past chairman of CSI Jaipur chapter, having teaching experience of 20 plus years. His core research areas include internet security, cloud computing, big data, and IoT. We have our next session chair, Professor Mary Hetting. She is an associate professor in University of Pretoria, South Africa. Ma'am, we welcome you. So she is an associate professor in the Department of Informatics at the University of Pretoria, South Africa. She coordinates the capstone module where information system final year students design and deliver a turnkey solution for a real life client. Her research areas are focused around the use of social media, human computer interaction and system analysis, and design education. It's an immense pleasure to welcome both the session chairs to this conference. We welcome you, sir. We welcome you, ma'am.
Very good afternoon and good evening to all of you. And I give my heartiest wishes for your successful presentations. Go ahead, please.
Thank you so much, sir. Thank you for your kind words.
Thank you for the welcome and good luck to all the presentations. I'm looking forward to hear everyone speak.
So I would like to start with our paper. So I would like to invite John Coffey to present his paper on a knowledge sharing approach to foster interdisciplinary pedestrian dynamics and epidemiological modeling research and practice. So, dear presenter, could you please proceed with your presentation?
I am, here we go, good. Okay, thank you very much. My name is John Coffey, and I have several colleagues. This work has been sponsored by the United States National Science Foundation. So an overview of my talk today is that I'll give a brief introduction to what I would like to do. I will briefly summarize related literature in 2 areas on knowledge sharing and on recommender systems. Then I will talk about the current system that we have built. It is a system called VIPRA Recommender System, VRS. And I'll give you some details about that just in a moment. I'll talk about the features in the system and I'll present a demo. I'll give you the results of a usability study in using the system. I'll discuss several points of interest and issues that we have identified as being open with our work. And then I'll finish with some conclusions. So as I said, this work pertains to VIPRA Recommender System, or VRS, and this is for the mathematical modeling of pedestrian dynamics and epidemiological modeling. The goal of the current work is to create a repository both for researchers and end users to describe and support suitable models for modeling pedestrian dynamics and disease spread, realistic parameter values that would work well for the modeling, and then also provide links for scientific literature and other descriptive resources to help users of this system have a deeper understanding of the workings of the models they're employing. With regard to the literature on knowledge sharing, there is this idea of knowledge repositories where codified knowledge from knowledge experts can be archived and made available for people, and also typically contact information for the people who have provided the knowledge in the system. There are these systems called expertise recommender and organizational memory systems, EROMS. The idea of these is that we are able to record organizational memory and then also make recommendations specifically for the experts from whom the knowledge came. Not necessarily making recommendations about how to utilize the knowledge. That is one of the things that differentiates our system. There are a variety of different motivations and barriers to knowledge sharing. Certainly within academia, we have publisher perish, as I'm sure everybody in the audience knows, and also the idea of enhancing one's reputation. There might be altruistic reasons for sharing knowledge, etc. Within industry, there are some fairly significant barriers to knowledge sharing, of course, because of proprietary knowledge or trade secrets, and just no real impetus at all to share things that might help competitors do better. There's a very nice paper on software engineering as pertains to knowledge sharing systems in terms of functional and non-functional requirements. So among the functional requirements would be good alerts that new knowledge is available, efficient search and categorization, or providing a good taxonomy is just another form of enabling the user to find the requisite knowledge that they seek. And also the ability to provide information regarding relevant experts who could be accessed. With regard to non-functional requirements, should have support for a variety of different media, should be easily accessible, should be reliable. Reliability becomes quite an issue because of the fact that we might, in a large corpus of knowledge, we might have contributing experts with differing opinions, and how does one sort out all of those sorts of things? So there are some issues with regard to reliability and consistency. Should certainly be easy to use, and a multi-level organization, of course, would facilitate search and finding the right stuff at the right time. Recommender systems historically have been in the realm of e-commerce, quite different from where knowledge sharing systems are. And they have been used in order to filter a large body of information about products and services and things. Typically, the recommender systems have been based on content-based filtering, where prior choices made by the user under question are used to make recommendations. Collaborative filtering is used to make stereotypes of various categories of users. And then when a new user comes, we figure out what stereotype that person meets, and we make recommendations based on others within the stereotype. Recommender systems can be based on either implicit or explicit models of user. Implicits are gleaned from the navigational habits of the user. Explicit, you ask the user a bunch of questions, and then you figure out what their interests are that way. There are a variety of problems for recommender systems, data sparsity and the cold start problem. This is if you just don't have any information on the user or on the things that the user seeks, you don't have much of a basis for making recommendations. The long tail problem is when you have a lot of items that don't have enough ratings to be able to make good recommendations on them. We found a very interesting study in the realm of healthcare and health improvement, and it basically was that they had elicited expert knowledge in order to build up their recommendations for health improvement. And this work suggested that not all recommender systems are based upon filtering large amounts of data, but might be built from expert knowledge. And that is exactly the way that we have proceeded with VRS. So then the current work, as I said, combines knowledge sharing and recommenders with the goal of broadening the use of pedestrian dynamics and epidemiological modeling across scientific domains. We also hope to demonstrate a means to share knowledge and recommendations in any knowledge domain. And the idea behind the current work, of course, is to have a tool that would be sort of a knowledge sharing environment ranging from academics trying to get their work out to public health officials who might be able to utilize that work. I'd like to give a quick demo, and this is the front page for VRS. I'm going to go ahead and navigate out to that now. So this is VIPA Recommender System. There is a 7-minute video overview of VRS, which is basically what I'm going to do interactively right now. If a person wants to just jump right in, there is a quick start for recommendations. And then if a user wants to navigate through different forms of models, they could choose to go to local models, local to global, or global models. I'll just check in here very quickly. Under global models, or for that matter, under any of these, typically the interface is divided into navigational capabilities, recommendations that might be available, and then external resources or references for an individual item. So maybe we have 2 global models right now, Zoo5 based on phylogeography. And we could get here, we could find a variety of resources pertaining to Zoo5, including their README pages, their GitHub repository, etc. If we wanted, I'll go ahead and jump into local models real quickly because that is somewhat more heavily populated. We have a quick start for local models. We also have various types of local models for which we have capabilities: social force, queuing-based, agent-based, cellular automata. These are various forms that mathematical modelings of pedestrian dynamics take. I'll jump into social force. I'll go to this one SPED, for instance, just choosing one at random. And then we could aggregate together individual parameters that are available. So maybe we wanted to do a model that pertained to boarding airplanes, and we wanted to superimpose over the way that the movement patterns as people board planes with how would disease spread over that. So then we could choose this. We get our parameter sets. The SPED model has been verified for the spread of a variety of different viruses, so we could choose whichever one we wanted here. This particular value is conditioned on virus type, and they're recommending 3.5 for this value. And I'm sorry I'm going quickly, but 12 minutes is a very little bit of time. Value here, I believe, is recommended as 6. The user could decide how many they wanted to claim as this number of people infected as it starts. The incubation time would need to be expressed. Since this is boarding pedestrians, it recommends that we say that they're half a meter apart. It says that they are walking to the plane in a particular range. We'll stay with the default here. We'll go for 1.0 here. Then we have a couple of model parameters that pertain to repulsive forces. So for instance, a repulsive force is as people get closer together, they tend to start to move further apart rather than colliding. We also need to get this repulsive force epsilon. We can choose the type of plane that we want to model. We'll stick with this. We could choose a boarding pattern. In fact, this work has been used by some folks who found that our recommendations were quite useful. These are measures for moving toward seats and putting items in the overhead compartments, etc. So when we do this, we get a JSON JavaScript object notation file that contains all of the parameters and the associated values that we have chosen. Got to get to my link here, sorry. So that is the way that that part would work. If we wanted to use the quick start, we could go here, we could get a quick start for local models, and we can find the various study types that are available. We can choose outputs we might want. We can specify the level of computational resources that we have. So I'm sorry for the whirlwind tour, but that's about all that time permits. Let me go ahead and jump back into my talk. So with regard to usability, we did a usability study in which we asked participants to view that tutorial video. Then they completed several activities, including determining a model and parameters for a pedestrian dynamics and disease spread modeling effort. We asked them to access an accompanying resource describing the workings of the model, and then to determine that they could identify a point of contact for the use of the model should they have further follow-up. After they completed these activities, they completed a Qualtrics survey based on the IBM Usability Instrument Post-Study System Usability Questionnaire, PSSUQ. Interestingly, though, this survey is 20 years old. It's a 5-point Likert scale. You know, Likert scales, they are essentially strongly agree, neutral, disagree, strongly disagree. And the participants would rank each of these on that particular way. Interestingly, the PSSUQ has all affirmatively stated questions. More modern versions of Likert scale questions will pose some like, overall, I am satisfied with how easy. That's an affirmative. There might be one, I am dissatisfied with blah, blah, blah. That would be a negative question. These are all affirmative, which is not really modern Likert scale, but it is verified. And it certainly made data summarization easy because now we could just put the number agreeing, strongly agreeing, et cetera, and we can get a result that looks like this. So with regard to system usefulness, we had very positive results on this, with only a few people even being neutral on how useful it was. With regard to information quality, we didn't do as well. Mainly, we didn't do as well on issues such as support with help and what to do if a user couldn't find what they wanted. So we really do need to make some improvements there, but it is a good start. And of course, usability is always done as an iterative process. You learn from a particular round of usability and you improve, and then you test again. Through this all, we have viewed knowledge sharing as a knowledge modeling activity where we make knowledge available in a variety of different means with a variety of different media. For our particular system, for the knowledgeable user, we have the hierarchical organization just working down through the levels of local or global models and then the types of local models, et cetera. So we have created what we hope is and found to be an easily navigable taxonomy of modeling approaches. For users who are less well acquainted with the knowledge domain, they can utilize the quick start capabilities and get into the system through that way. We felt it critical to provide a link to accompanying resources and references, and this enables the model developer to share deep knowledge of the workings of the model and for the user to delve into those details. We do note in our discussion that there are significant differences between our recommender system and traditional recommendation systems, mainly because of the fact that data mining is the fundamental approach for traditional recommenders. Expert knowledge elicitation has been the approach that we have employed. However, I will say that with regard to getting started, that cold start problem where you start with very little information about users or resources, we are next exploring a semi-automated approach, and I'll say a little bit more about that in the conclusions. Also, the literature on recommender systems mainly pertains to systems built with implicit user models, data gleaned from large collections, and as I say, our system contrasts to some degree with that. Regarding the usability study, participants did find the system generally to be quite usable. We did note some deficiencies, which we hope to ameliorate in the next round. Participants were university seniors majoring in computer science, and therefore there is a non-randomness about that because our users were disproportionately very good software users. However, we do note that we probably would have a target audience that would be non-random as well, because they would, on average, have good end user skills as well, if a person is in public health, for instance. So we view our system as a step toward sharing the use of important modeling capabilities across research domains from academic researchers to public health officials. We view VRS as a way to provide an information space where researchers could make their academic work more widely available and more useful for practitioners in the field. We view VRS as a proof of concept for the integration of knowledge sharing systems and recommender systems, and with a broader view of recommender systems beyond those that simply filter large bodies of content. In the future, we will be adding more expert-based models to the system, but we're also looking, and I've already started developing this, a mixed initiative human-machine method for adding new models and parameters. The interesting point here is there's this notion of variable autonomy in agent-based systems where you let the agent do whatever it can in an automated fashion, and then humans intervene to fix whatever is needed. So variable autonomy means the system may be relatively more or less autonomous depending on what the particular issue is. That is where we hope to go next. So I thank you very much. I'm talking from sunny Florida. It is about 65 degrees outside, and that is our beach. I would be happy to take any questions.
So can you hear me?
I can just fine.
So Professor Coffee, it was a very nice presentation, and I think it's a perfect presentation. Very nice. You presented all the features, all the aspects, and you also shown that implementation model also. So looks very good from my side. Just one query: in the survey results, you are telling that the information quality was neutral for the 16, and it was strongly agreed for 18 or something. So what is the reason for that? Why is that much of neutral for that response?
The best takeaway that we did some follow-up, I didn't put any of the anecdotal evidence in because when people write comments, that's considered some of the lowest quality information. So I didn't really go into that. But what we did tend to hear, as I say, was that the help function was the main thing was that the help function needs to be improved. Particularly, if a person had chosen to have limited computational capabilities, it is okay, well, what do we do now? And we didn't help very much with that. Also, we had students who were now reading academic papers that were outside of their domain of expertise. And of course, this is mathematical modeling, which does tend to be very, very heavy on differential equations and stuff. And so the students felt that the scholarly papers didn't really provide information that was as valuable as maybe some more practical layperson level information.
Yeah. So one more thing I would like to ask you, that you told that it's an NSF funded project. So
Yes.
is it a collaborative project, or you are doing your alone or something like that?
Oh, well, I have pretty single-handedly done the work on this, but I do have collaborators, Robert Polly at NYU. Ashok Srinivasan is our eminent scholar at the University of West Florida. Suresh Namali is at Embry-Riddle, and Matthew Scotch is at Arizona State University. I'm sorry, I really should have mentioned that up front, but I'm sweating bullets for getting this in 12 minutes, to tell you the truth.
That's truly admirable work. Very nice. And thank you so much for putting such a nice work towards the community.
Thank you so much, sir. I'll stop sharing my screen. Oh, yes, I should stop sharing screen.
Thank you for your presentation. Now moving on to the next presentation, I would like to invite Farah Sinada to present her paper on a study on image enhancement and noise filtering of Kato-Kurt's images. Dear presenter, could you please proceed with your presentation?
Yes, hi, I'm just going to share my screen. Yeah, can you see the presentation?
Mhm.
Yes, we
Yes.
can see.
Okay, so hi, my name is Farah Sinada. I'm part of the Applied DSP and VLSI Research Group at the University of Westminster, and I'm going to be talking today about a study that we conducted on image enhancement and noise filtering of CATO-CATS images. So I'm going to begin sorry, can you see my,
Yes, we can see. But you are not audible.
can you hear me now?
Yes, we can hear you now.
Yes, so neglected tropical diseases affect more than 24% of the world's population. And they mainly affect people in subtropical areas, and they have a huge negative impact on a patient's life. They're a huge burden both economically and socially. And especially in children, they tend to cause stunted growth and development, and they do affect school performance. The major issue here is that drug treatment is available, but there are issues with diagnosis and resource management. So one of the methods that's used to diagnose these diseases is called the CATO-CATS technique, and it's the most commonly used technique for those diseases. It commonly examines stool samples under a microscope. And the most important thing about the CATO-CATS technique is that it requires minimal processing, no centrifuge or staining, so it's inexpensive. However, it is labor and time intensive, as it requires a clinician to look at a slide image under a microscope and to manually tally eggs. So as you can see on the image on the side, there's an image of a clinician who is who is preparing slides to be processed. There's also the issue of a time limit, as the samples must be processed in around 2 hours, otherwise the samples do tend to degrade. So I've got here an image feature. I've got a CATO-CATS image here on the right, and in it I've highlighted the eggs using arrows. So as you can see, CATO-CATS images are quite difficult to process. They're very complex in nature. They've got a lot of spurious intensity patterns, so lots of areas of intense dark and intense light pixel intensities, and lots of objects with similar characteristics to the parasitic eggs. And the eggs themselves, due to the way in which the samples are prepared, tend to lose their distinctive edge, their continuous distinctive edge. So the next thing we're going to do then is to find a way to improve these images and to improve the quality. And to do that, one technique that we looked at was noise filtering. So it's a pre-processing step that can improve image quality and improve object detection algorithms. And we can think of noise sort of as an added layer to an image that we want to remove to improve the image quality. There were 4 methods that we explored. There were the rank order filter, Gabor filter, adding and removing noise with the Wiener filter, and entropy. So the rank order filter is a method that allows us to organize our impulses in a signal by rank. It allows us to isolate noise frequency, and we can control the window size, so the size of the neighborhood, and the percentile. And the percentile controls how the pixel values are ordered in that neighborhood. So I've got a couple of different results. They're difficult to see, but just in general, I've got 4 different columns. The first column has each color denotes a window size. So green is a window size of 2, red is a window size of 4, yellow is a window size of 6, and purple is a window size of 8. And each row is 1 percentile. So the first row is the 5th percentile, the middle row is 50th, and the bottom row is 95th. And it's a bit difficult to tell from these images. I'm sure about that, but basically what it is that the smaller the window size, the less effect it has on the image. The bigger the window size, the more effect it has on the image. But due to the fact that there's all these different types of noise in the image, we also start to degrade the egg cell borders and the egg cell features. So if you look at the very last column, the purple column, the image is basically unreadable. All the eggs have disappeared. And the results are very similar to applying morphological images. So the thought process was, if we could not clean up the images due to the fact that it is so deeply complex, perhaps we may be able to characterize the different elements in an image using a different technique. And for that, we looked at the Gabor filter. So the Gabor filter is a linear filter for texture analysis, and it can commonly be used to characterize different elements in an image. This is just two different examples using one wavelength of 4 and an orientation of 90 degrees. And the top image, the top row, is Gabor filter applied to the entire image, and the bottom row is applied to a smaller subsection. And essentially what we were hoping to find was strong gradients or strong magnitude and phase around the cell borders, so something that allows us to see or characterize the cell borders, or something that allows us to characterize other elements in the image. Unfortunately, due to the fact that there's so many different elements in the image, and so many different objects that might appear as the eggs themselves, we get a lot of conflicting information. So we can see that in the phase and the magnitude, they're pointing in many different directions, which is very difficult to use to characterize any different element in the image. And so if we can't characterize the noise, then perhaps the next thing we could try is to remove the noise entirely. So the next thing we could do was to then look at noise removal techniques. And what we did was to try to look at different noise removal techniques. So what we would do is we'd add different types of noise, such as salt and pepper, speckled Poisson local variance, and Gaussian noise, and then remove it using the Wiener filter and look at the effect. This is a common technique that's usually used to remove added signal noise to images. So I've got only a couple of results to show you because there isn't too much time, but essentially this is using the Wiener filter on its own without any added noise, and it has the effect of smoothing out the images slightly. It's not enough to make enough of a difference when you're trying to do object identification, but it's sort of set there as a control. And I've got two examples. So I've got salt and pepper noise and Gaussian noise. So the image on the far left is the original image. The image in the middle is the image with added noise. And the image on the far right is the image with added noise and then filtered using the Wiener filter. As you can see, the image on the far right comes out much worse than it did at the very beginning. And that's probably because the added noise is too similar to the different pixel intensity variations inside the image itself. And so to try and remove it, instead, what happens is we don't end up removing as much as we have added. And it has the effect of essentially making the image quality worse and making it more difficult to be able to pick out the eggs inside the images. And we tested this also in smaller subsections, so it's easier to see here that the eggs themselves at the very end, they start to lose their cell borders and their continuity, so it's difficult to then pick them out as objects. So the final thing we did then was to try and see whether we can measure this randomness. If there's so much randomness in the image, maybe we can look at it and see whether we can characterize it, and that is what we did using entropy. So entropy is basically a statistical measure of randomness, and we wanted to see whether we could compare the different elements in the image, measure their entropy, and see whether we can characterize that in some way. So on the image on the left, I've highlighted two of the eggs. So we would pick out the eggs, measure their entropy, and then compare that against other regions that had a similar shape and size as the egg regions. And the table on the right shows you that the values that we got were extremely similar. In fact, they're so similar that you couldn't tell them apart. So it's then not too difficult to try to separate those two areas from each other using only entropy. So essentially, working with KTOCAT's images, I didn't have enough time to go through everything that we have done before, but the ADVRG group has done a lot of work with KTOCAT's images before, and it's a novel work as these types of images, highly textured images aren't studied as much. And so essentially we're recording all the different methods that we have tried to improve image quality in our final aim to create object detection algorithms. So KTOCAT's images themselves present unique challenges as textured images respond quite differently to common noise removal techniques. So in conclusion, we've tried around 4 various noise removal techniques. KTOCAT's images are highly textured and complex. Due to their intensity patterns and the discontinuous egg walls and objects that have a similar appearance and characteristics to the different regions of interest. There were some methods that had some good results, but the problem is that we want to be able to apply this to all the images in a specific data set. And so having to do this and manually choose the best method for each and every single image is not really viable. So essentially further work was moving away from techniques that focus on pixel point operations and to move towards techniques that were more abstract, and techniques such as feature extraction, segmentation, that looked at different regions within the image to try to develop an object identification algorithm. Thanks for listening. I hope you have any, you can ask me any questions if you've got any.
It was such a nice presentation and congratulations to you for that. Am I audible?
Yes.
Okay. So I think everything was good, but can you tell me, is there still some limitations which you want to improve in this project?
Yes,
any limitations?
absolutely. Yes, so because these types of images haven't been studied before, what we're doing is testing out many different approaches. So we've published before, we've looked at morphological operations, we've looked at different feature segmentation algorithms, and we're just documenting our work using all the commonly used algorithms on highly textured images. So from noise, essentially from noise removal, these techniques are not as successful on these types of images. And what we have moved towards is to instead find regions of interest and then clear up those small regions by themselves instead of trying to apply something to an entire image.
I had a quick question, if I could.
Yeah.
So is the target audience for this human review, or would there be pattern recognition in a software program? And would there be a difference in what would be optimal for human recognition versus pattern recognizing program? Would you optimize differently for those two?
That's a really good question. So the end result is a software pattern recognition program. And the aim is to essentially create a diagnostic tool that is helpful for clinicians because of the issues of resources and the way that these communities have to deal with not having enough resources. Essentially, you'd have like 3 technicians who have to go through 30 plus samples in a matter of days. So the aim is to create a software that can then do the manual tallying of eggs inside the image slides. So yes, there is a difference in developing this for humans versus developing it for the software. As the clinicians themselves, they scan the image in a different way when they were trying to find eggs, and for the software, because of the way the diseases themselves are diagnosed, you need a range, so percentage, so perhaps 12% infected or 15% infected, not a specific number of eggs in a sample. So it's more important to be able to pick up eggs and be sure that they're eggs than to pick up all of the eggs and also pick up 20 false regions.
Thank you very much.
Yeah. Any other questions?
Yeah. Okay. Thank you very much.
Thank you. I will stop sharing.
Thank you so much, ma'am, for your presentation.
Thank you.
Moving on to the next presentation, I would like to invite Shrikant Pawar to present his paper on addressing class imbalance problem in semantic segmentation using binary focal loss. Dear presenter, could you please proceed with your presentation? Okay. Moving on to the next presentation, we have Dennis to present his paper on AI applications in environmental, cultural, and geological heritage conservation. Dear presenter, could you please proceed with your presentation?
Good afternoon. Do you hear me?
Yes, we can hear you.
Okay, wait a minute. I will share my screen. So, do you see the screen? Is my presentation
Yes.
available? Do you see it? Okay, great. So, big screen. Okay, so yeah, we're going to talk about application of artificial intelligence for conservation purposes, and in our case, I want to discuss not only the conservation of, for example, biodiversity or geoheritage or cultural heritage, but all together. Because these things are rarely considered together, and applications of artificial intelligence in these areas are also not frequently considered. So all these problems arise. The problems arise mostly because of competition for land. Today, especially in developing countries, there are expanding infrastructural projects such as road projects. Maybe, yeah, I think most of you have heard about Belt and Road project, or, for example, Build the Better World. All these transnational road projects, as well as agricultural and forestry activities. All these activities competition for land, and as a result, it is problematic to conserve biodiversity as well as cultural sites and geoheritage. And when they are considered separately, this again makes even more challenge. At the same time, it is often observed that both cultural sites and biodiversity sites, as well as geodiverse sites, are often coinciding, which means that basically if we pull these efforts together and we actually try to identify the sites that concentrate all these three different aspects, we can do it more effectively. But it is, of course, very challenging. So this is challenging, as I already mentioned, actually competition for land and limited resources. And it is a complex task because, first of all, the sites needs to be actually identified. They also need to be actually implemented, managed, and it is also necessary to make the forecast what will happen in future to this site because of changing environmental conditions. And in addition to that, it is important to manage stakeholders. So the tasks are really complex, and these tasks are, they lead to high level of uncertainty because we don't know exactly how will for example, environment change in future. How will this affect distribution of species? For example, we conserve an area where we think it's high biodiversity, but if climate changes, these species can move out of this site. And the same thing with cultural issues. So it is a complex task, and it often involves resolution of multiple conflicting interests. Sometimes, for example, indigenous people don't support conservation actions, and there are many interesting and complex situations. And obviously, for this purpose, application of AI tool could be very helpful. So I'm trying to argue here that the approach is it is essential to apply an integrated approach to site selection. And again, AI and machine learning tools can be very helpful here. So for which purposes? So first of all, we can analysis, and we integrate data on different spatial and temporal scales. This is a very complex task, but it can be done with application of integrated tools from geoinformation technologies and AI. I'm talking in more detail about the technologies in the paper. Also, integration of data that we collect from different sources. So, for example, very often we will have, let's say we need information on a regional scale. We can collect data from satellite imagery, but at the same time, to get a more precise data, we need to collect information in the field, and integrating this with, for example, the information from LiDAR images can provide the richest information. And this, again, integrating this all together is a difficult task, and application of AI tools could be actually very helpful here. And as I already mentioned, climate is changing, and forecasting is very useful here. There are many interesting developments in AI that can help forecasting climate. For example, a recent paper was talking about application of generative neural networks, or GNNs, to actually simulate possible climate changes. So there are many approaches. Obviously, machine learning is about forecasting to a large extent, and we can use the tools here. Now talking about communication. So as I already mentioned, there are many conflicts. So these include conflicts for land use between different political groups and different actually groups of stakeholders, business groups, local people, indigenous communities, and yeah, many others. So this is not a simple task, but again, it can be facilitated by application of AI tools. First of all, planning can help to find compromises. So if all stakeholders are involved in the planning process, and this planning process can be actually facilitated by usage of scenario planning tools, and scenarios again can be developed through application of AI tools that can help make forecasts. At the same time, yeah, here I have a summary, so we can actually facilitate landscape assessment and identify priorities. Also, we can develop scenarios and find win-win solutions this way, communicate, we can automate communication, and this can help us to communicate at scale with the general public and key stakeholders. And AI can also help us to manage relationships, so we can identify key decision makers. I will talk about this in a few slides, how this can be done. So first of all, yes, it is important to evaluate the value of ecosystem services to actually pitch for the land, and not only ecosystem, but also cultural services. There are already very popular packages such as ARIES and Invest that can be used for this purpose. This information again can be integrated with scenario planning tools. But what is really interesting in my view, it is application of actually graph neural networks for stakeholder management. So it is already widely applied in marketing, where we can identify links between stakeholders. But it is, to my best knowledge, I don't know the cases when it was applied in actually nature conservation projects. However, it has a great potential because we can identify actually which people can be influenced through their network. So this is a really powerful tool. Yeah, of course, we not only need to actually identify the sites and resolve the conflicts, but we also need to manage the sites. So we, for example, identified and established a area where we conserve, for example, diversity, maybe some indigenous people and their cultural objects, and we also conserve some geoheritage. And here we need to prevent some actions. Obviously, we don't want someone to hunt, for example, in the protected areas. We also need to detect long-term changes that can lead to real problems, as I mentioned, for example, climate change or erosion or something else. And also we need to control recreational activity, so people can damage actually the system if it is not under control. So here are some risks of application of AI tools. Again, all these tasks can be facilitated by machine learning tools, especially application of drone technology and real-time monitoring and reporting tools. But of course, all these tools have risks. For example, if we are enforcing the law, there can be wrong data interpretation, which can lead to problems. Again, surveillance can result in wrong signals. So these risks need to be taken into account. And in our paper, we also propose some possible solutions to these problems. All these tools are, of course, applied the best if we apply them together. So this it is a good idea to integrate them and also to ensure that the learning continues. So this is again, in business, it is already a well-established process, including such tools as MLflow and others. But in any case, it is a good idea to establish an ETL process that would create the pipeline, would extract data, then transform it, and then actually load it to the systems that will implement actually machine learning algorithms. So this is a good idea to create, again, integrated pipelines that would update the machine learning algorithms and actually help to maintain conservation sites. So this is an important aspect that needs to be considered. And that's all that I wanted to say. So thank you for your attention.
So, Mr. Dennis, can you hear me?
Yes.
So you are conserving the heritage of the nation. That's good. They are using AI for that. So can you
Yes.
tell me what was the motivation for you to do this project?
Yeah, the motivation is that I am myself working in nature conservation, and I'm looking for opportunities to implement, for example, nature-based solutions that integrate human well-being and actually nature problems. And I see that these tools are not quite frequently used, and at least even if they are used in a limited form. So, for example, in conservation, obviously, for GIS purposes, like to classify maps, everyone uses AI tools, but it's rarely to communicate information that there are much more possible uses that can facilitate this process.
That's very nice. Very nice. Good. Thank you
Okay.
so much.
Thank you.
Thank you. Thank you so much for your presentation.
Thank you.
Now I would like to invite Cecilia Irene to present her paper on comparative study of KDD and CRISP-DM methodologies for phishing identification. Dear presenter, could you please proceed with your presentation?
Yes. Can you see my presentation?
Yes, it's
Yes.
visible.
Yes.
Thank you. Thanks for the opportunity to present our results. Thank you so much for being here. I tell about our research work entitled Comparative Study of Knowledge Discovery Databases Process and Cross-Industry Standard Process Data Mining Methodologies for Phishing Identification. The authors in this paper are Esteban Zabaleta, Gabriel Dominguez, Eddie Sanchez, and me, Cecilia Loesa, from the National Technological Misantla campus. We focus on classified data originated from phishing website records. The presentation will have these contents, introductions, study, materials and methodologies, results and findings, and future work. The motivation for this work is that phishing are techniques or methods of cybercrime that may compromise the privacy and security of individuals, cause financial losses, damage the reputation of the affected companies or people, undermine trust in online services, and facilitate the spread of malware. Hence, our proposed solution or contribution is conduct to a comparative study of two methodologies for machine learning, KDD and CRISP-DM. We employ machine learning algorithms, and this research is established in the domain of experimental machine learning. Now I will show the materials and methodologies used in this work. To carry out the experiments, we acquire records from the Mendeley repository corresponding to a collection of ARL attributes or legitimate and phishing websites. These datasets were selected because it has been carefully constructed and considers features relevant to identify phishing sites, such as URL characteristics, page contents, domain features, among others. In addition, it is publicly available, allowing other researchers and cybersecurity professionals to assess it and use for their experiments and evaluation. Also, the dataset provides enough samples of phishing websites and legitimate websites. allowing for different experiments. The first methodology was KDD, knowledge discovery in databases. The phases are selection, preprocessing, transformation, data meaning, interpretation, or evaluation. In the selection phase of this methodology, we identify phishing as the focal point of our study. Phishing, as many of you might know, is a malicious cybercrime tactic that involves deceiving individuals to obtain sensitive information, such as passwords, credit card numbers, or personal details. In our study, preprocessing and transformation phases, we eliminate different attributes with constant values to simplify our data and enhance the quality of our analysis. The second methodology was CRISDN, Cross-Industry Standard Process. CRISDN allows standardized data mining processes across different industries. It is a six-phase methodology that naturally describes the machine learning process or data science process. And the phases are business understanding, data understanding, data preparation, modeling, evaluation, and deployment. In the KDD methodology, business understanding and data understanding corresponds to the selection phases, while preprocessing and transformation of KDD corresponds to data preparation. A personal computer with Windows operating system of 64 bits, Intel i3 processor, and 8 GB RAM was used to carry out the experimental phase. For KDD, we employed the tool Orange for implement the algorithm naivages, while in IBM statistics, we implemented multi-layer perceptron and radial basis network. The algorithms were selected based on a review of the literature, where it was found that they perform very well and can obtain competitive results. Now I will comment on the results obtained. To obtain the results on the KDD methodology, the NAI algorithm was implemented with different configurations in the sites of division criteria. In the size of the training with partitions, 60, 40%, 70, 30%, and 80, 20% for training. Also by tenfold cross-validation. As shown in the table 1, the best results for the KDD test was obtained employing cross-validation, obtaining 86.7% for F1 metric. On the other hand, for the results of CRISDN, a data split was established in 73% and 80-20%. Multi-layer perceptron and radial basis network were used to perform experiments considering 1 to 10 layers. As can be seen, multi-layer perceptron showed its best result using 10 layers, while in the case of the radial base network, it does in 9 layers. Also, when using perceptron multilayer, correctly identified the 92 0.9% of pages is affected by phishing, while you see the radial base network correctly identify the 83.8% of pages affected by phishing. The percentages of false results correspond respectively to the true positives 5,643 and 7,763 of the corresponding confusion matrices for the algorithms multi-layer perceptron and radial base network. Now I will show the conclusions. The focus of this study was conduct a comparative study using KDD and Christian methodologies for phishing identification. The KDD and Christian provide a different level of detail in the activities to be carried out in each of the phases, which might affect the results obtained. Also, a relevant aspect found in these methodologies is the ability to go back to previous phases. With this, it was possible to determine if there were values or elements that may not allow a good performance of the implemented algorithm, and therefore allows making improvements in the configuration. As future work is considered the following: the last phase of Christian will be determined as a case study where our conclusions and observations can provide a point of support to perform, for example, an executive report and bar charts. Also implement different methodologies to identify phishing, such as SEMA, Agile KDD, and Agile Christian. To perform a comparative study on another data sets with different metrics, and perform another experiments with different algorithms. This study is part of the MENLAB project, MENLAB methodology for experiments with machine learning algorithms, where we seek to develop a novel and widespread approach to project development across multiple disciplines. It's all for the presentation. Thank you for your attention.
So your name is Mejia. Can you tell your name? What is your name, please?
My name is Cecilia Irene and last name Loesa.
Oh, great. So it was a very nice presentation. So can you tell something about your comparative studies with the other similar works with your outcome?
Can you repeat, please?
Have you compared your results with the existing results?
No, the results we obtain are part of the MENLAB project. So we only compare the results between these two methodologies.
Okay, fine. Good, thank you.
Thank you.
I'm sorry for just a very basic, not really related to your talk question, but I'm on the Mendeley data website and it reads download all 1.73 gigabytes. And then below that, it has files, data set, and index SQL 9 megabytes. Which, what was the size of the data set that, oh, you used 24 megabytes. Yes.
Yes, it is this.
Thank you very much. I'm sorry, I missed that. A very, very interesting talk.
Thank you.
Okay, thank you so much.
Any further questions?
No, no questions.
Okay, thank you so much for your wonderful presentation.
Hello.
Now,
Yes, I have a question.
yeah, yes,
Okay.
please.
Yeah, Cecilia, what is the importance of using methodologies?
We consider that it is an important area to explore in machine learning. Since we carry out a survey around the world and identify that currently the machine learning field is more than an art than a science, which is important to work to develop different methodologies and implement to be or to allow the improvement in different studies and also facilitate the reproducibility of the works.
Okay, thank you.
Thank you.
Thank you so much. Moving on to the next presentation, I would like to invite Peter to present his paper on the experience of statistical processing of memes in big data format. Dear presenter, could you please proceed with your presentation?
Hello, can you hear me?
Yes, we can hear you.
Wonderful. One moment. So you can see the screen, right?
Yes, it's visible. You may please proceed.
My name is Petr Gorbunov, and I would like to tell you about a scientific study conducted jointly with my scientific supervisors, Radmonga Potapova and Vsevolod Potapov. The study is called On the Experience of Statistical Processing of Memes in Big Data Format. The intense development of information technology has significantly affected most of the scientific disciplines, including applied linguistics. Having received new research tools as well as material for conducting scientific research, it identified a number of problematic issues that the world of science faced in the era of digitalization. One of them was the issue of interpersonal communication of internet communicants in the light of the hermeneutic typology of semiotic and semantic patterns of toxicity in network communication. The main purpose of the study was to investigate polycode digital content containing the explication of the toxicity parameter, which affects the cognitive reformatting of the worldview on the part of participants in social network communication. One of the tasks was to collect a large-scale multimodal polycode linguistic databases of memes using big data processing technologies and a system for in-depth annotation of polycode texts. The data source was the Russian language, English American language, and German language segments of the Internet. Regular analysis of the World Wide Web with the continuous replenishment of the database described above makes it possible to monitor the topical and code dynamics of the language material for each of the language segments. The solution to the problem of collecting linguistic internet material is based on the existing means of big data processing with the available software resources of modern electronic computers and cloud services. The main tool for quantitative tracking and analysis of the collected materials was the Microsoft Excel spreadsheet, which is the part of the Microsoft Office package. And the choice of this software is conditioned in part by its full compatibility with the relational databases commonly used in cloud services such as Microsoft Azure and Google Drive. This software has been successfully adapted for the storage and processing of linguistic information obtained in previous studies. Um, to obtain the most objective results when collecting a large-scale multimodal polycode database of memes, it is necessary to establish a number of criteria according to which its primary description will be provided. First of all, it's important to focus on the fact that the main task of the study is to determine the topical and code dynamics of internet postings within a certain time frame. Thus, taking into account the rapidly changing interests of the youth part of modern society that most actively uses the internet, the most optimal time period for keeping tracks of the changes taking place in the language material is an annual quarter of 3 calendar months. In turn, to build primary tables covering each of the language segments, it is necessary to take into account a number of factors. First of all, for each of the collected memes, its topical content and detailed code representation, I mean text, image, audio, or video, are determined. It's important to consider that internet memes are predominantly polycode. However, they are also monocode variations. The principle of dividing material according to codes is presented in the picture and is intended to cover the entire palette of currently existing types of memes. Secondly, in order to determine the topical focus of the material, it is divided into appropriate micro and macro segments, examples of which are presented in the picture. The division of internet postings into micro and macro segments implies different levels of integration. At the moment, one can identify 12 most frequent macro segments, which include the overwhelming variety of memes on the World Wide Web. Within each macro segment, quarterly statistics are provided on the basis of the frequency of occurrence of a particular microsegment of the internet, as well as the frequency of codes used. For all the above parameters in relation to 3 language segments, a comparative analysis is performed in pairs and in the aggregate. Russian language, English language, Russian language, German language, English language, German language. As a result of annotating and statistical processing of the collected material according to the criteria presented above, and with the help of modern information technologies, the following general language trends were identified that are characteristic of each of the linguistic internet spaces covered in the study. First of all, it's polycode memes that have received the greatest distribution in internet communications. In particular, these are memes in which such types of codes as text and image are presented together. Secondly, the internet community reacts most dynamically to topics that fall under the international relations macro segment. Within this macro segment, the change in trending topics for internet postings in the 3 language groups occurs quarterly, often becoming completely situational in nature. It is interesting that the Russian language and English language internet segments react more sharply to the changes taking place in the world, while German language memes reflect the internal problems of German society in most cases. There are a number of macro segments for which the statistics hardly change over time for all languages. These segments include work and education, healthcare, interpersonal relations, and personal interests and hobbies. The worldview of a person takes its shape depending on the digital information flows surrounding they as internet user. Thanks to the interdisciplinary, convergent hermeneutic approach, it becomes possible to study in more detail the problem of the functional relationships between the implicit semantic context of digital meme communication samples and its influence on changing the worldview of users the World Wide Web. According to the preliminary studies, two types of toxicity in network communication should be distinguished: explicit and implicit. A characteristic feature of explicit toxicity is the presence of obscene vocabulary in online discourse, which is most typical for the Russian language. On the other hand, implicit toxicity is not identified from a linguistic point of view, but is reflected in cases of gaming and gambling. It is this type of toxicity that correlates with a certain type of cyber threats that are currently being implemented in the field of digital communication. State-of-the-art digital tools provide flexible options for processing linguistic information. With regard to the research project described above, they enable not only the use of the standard options of programs for the formation and analysis of text corpora, but also annotation of the collected databases, ensuring work with metadata and adjustment to specific research goals. Thank you for your attention.
Thank you so much for your presentation. Any questions?
No questions from my side. It was a good presentation.
I've got a question. So, forgive me if you've already spoken about this, but how do you work on the tonal messages that memes sometimes have? So, for example, how do you differentiate between a meme that's being sarcastic about a specific problem or a meme that's being serious about a specific issue? Do you use a specific language type model to differentiate between that? Yeah.
Thanks for your question. You know, right now we do not have a method to identify memes, whether they are sarcastic or kind or evil, so and so on. Still, our research group was so there were 10 people who were collecting this database, and in situations when we couldn't, so somebody couldn't identify the tone of the meme, his colleagues or her colleagues helped, and there was some kind of discussion about some particular meme, whether it is I don't know, kind or evil, whether it is sarcastic or whether it is funny, and so on.
Thank you. So I guess then, how would you then differentiate them, especially with memes, for example, that don't have text, that are just images? There's a lot of subtext in them quite a lot of time. So how do you then categorize those types of memes?
So the same situation, you know, when you read a book or when you read some text, you you have your own I don't know, you have your own position. You just I don't know. mm, So the method is the same. When you read the text or when you look at the picture, you can understand whether you like it or whether you do not like it. whether so the mood, you can understand the mood of the author, or at least you can try to understand it.
Okay, thank you.
Thank you so much for your presentation. To the next presentation, could you please unshare? Yeah, thank you so much. Moving on to the next presentation, I would like to invite Mohammad Sabiri to present his paper on quantum codes from cyclical codes over the ring. Dear presenter, could you please proceed with your presentation? Sabri
Hello?
sir?
You can you hear me?
Yes,
Yeah,
yes, now we can hear
Yeah.
you.
now we
Yeah.
can hear you.
Thank you. My topic is about quantum codes from cyclic codes over the ring R, where R equal to FQ plus U VFQ plus VFQ plus U VFQ plus U square plus V square FQ plus U V square FQ. The plan of my presentation is as follows. First, we give some preliminaries. Secondly, we give the definition of codes over R. Thirdly, we define the gray map. And then after we give some characterization of cyclic codes over R. And we end up giving some quantum codes by using cyclic codes over the ring R. Quantum codes are fundamental to the error prediction in quantum computer. Several families of good or optimal quantum codes were constructed by several research over time. The CSS code construction is one of the most interesting code constructions shown in the literature. In fact, it is the first construction method exhibited in the literature in the sense that one can deal families of quantum codes by applying such constructions and not only few codes with specific parameters. Such method it leads to classical linear Nicis code or an Euclidean self-orthogonal linear code to address the problem of correcting phase and qubits 5 errors. The CSS codes form a subclass of the class of stabilizer codes. The process starts with two binary linear codes, C2 and C1, with parameters n k1 d1 and n k2 d2 respectively, such that C2 is included in C1 and but orthogonal of C2 and C1 correct errors. Based on these classical codes, or quantum codes is defined. In our work, we use the CSS construction in order to give some quantum codes over the ring R. Let R equal to FQ plus U VFQ plus VFQ plus U VFQ plus V square FQ plus U V FQ plus U V square FQ, with U square equal to U, V cube equal to V, and U V equal to VU. We define epsilon 1, epsilon 2, epsilon 3, epsilon 4, epsilon 5, epsilon 6 as follows. We have epsilon 1 plus epsilon 2 plus epsilon 3 plus epsilon 4 plus epsilon 5 plus epsilon 6 equal to 1. And R is equal to direct sum of epsilon IR. And for any R in R, we have R equal to sum from 1 to 6 of epsilon II, where II is in FQ. The rank R is a finite non-chain rank. It is a semi-simple rank. In this work, the idempotent decomposition used to give the parameters of quantum codes over the rank R by using cyclic codes over the rank R. As codes over finite rank or code C of Langit N over R is a subset of Rn, and C is linear if and only if C is an R submodel of Rn. And for a linear code C, if every C0, C1, Cn minus 1 in C implies that Cn minus 1, C0, Cn minus 2 in C, then C is a cyclic code. In this paper, we always assume that C is a linear code over R. We give the definition of, we define the gray map as follows. Phi is defined from Rn to Fq6n, where M is an invertible matrix of order 6. This application phi aims to give the relationship between cos over R of Langit N and cos of Langit 6n over Fq. The gray map is a weight preserving and distance preserving map from C to phi of C. For a code C, we define Ci as the set of elements II in Fqn such that there exists I1, II minus 1, I plus 1, I6 in Fqn such that sum from 1 to 6 of I epsilon I in C. Ci are linear codes of Langit N over Fq, and every code C of Langit N over R has the following form. Further, the matrix G generates C over R, where Gi are generator matrix of Ci. For a code C over R, then C is cyclic code if and only if Ci I from 1 to 6 are cyclic codes over R. Don't forget that Ci are linear codes of Langit N over R, and C is a code of Langit N over the rank R. Let's see, be a cyclic code. There exists a unique polynomial G of X in Rx such that G of X divides Xn minus N, and G of X generates C. G of X has the following form, where Gi of X are the generator polynomial of Ci. Let's C equal to epsilon 1 C1 plus epsilon 2 C2 plus epsilon 3 C3 plus epsilon 4 C4 plus epsilon 5 C5 plus epsilon 6 C6 cyclic code generated by G of X, then orthogonal of C is included in C if and only if for any I from 1 to 6 we have the following condition, where Gi star of X are the reciprocal polynomial of Gi of X respectively for I from 1 to 6. And then for code C over R, orthogonal C is included in C if and only if orthogonal Ci is included in I from all I. Let's see, be a linear code of Langit N over R, then orthogonal of C is sum from 1 to 6 of epsilon I orthogonal Ci, and C is Euclidean self orthogonal code over R if and only if C1, C5, and C6 are all Euclidean self orthogonal codes over Fq. Now we give the theorem 7 of theorem of construction of quantum codes. Let's see, be a cyclic code over R. If orthogonal Ci is included in Ci, then orthogonal of C is included in C, and there exists a quantum error correction code with parameters 6 and 2k minus 6 and dl, where dl is the binary weight of the code C, and k is the dimension of the code phi of C. We'll look for application of C as construction in order to have quantum code over this rank R. For this, we look for codes containing their reals. By using magma, we give some examples. Let Fq equal to F23 and N equal to 23. We have X 23 minus n equal to x plus 22 power 23 in f23 of x. For g1 of x equal to j2 equal to j4 equal to j5 equal to j6 of x equal to 1 plus 21 x plus x squared. For all ICI is an 23, 21, 3 cyclic code over F23. The code C is cyclic of length 23 over R. As Gi of x, Gi star of x divide x23 minus 1. Orthogonal of C is included in C. Phi of C is an 138, 126, 3 codes over F23. Then an quantum code is given by theorem 7 of parameters 138, 114, 3. For FQ equal to F14 and N equal to 39, the factorization of x 39 minus 1 is given as follows. For J1 of x equal to J2 of x equal to x plus 10, G3 of x equal to J4 of x equal to x plus 4, and G5 of x equal to G6 of x equal to x plus 12. CIR 39, 30I2 cyclic cos over F13. The code C is cyclic of length 39. Consequently, orthogonal of C is included in C. P of C is an 234, 228, 2 codes over F13, and an quantum code is given by theorem 7 for parameters 234, 222. So for FQ equal to F19 and N equal to 19, we have x19 minus 1 equal to x plus 18 power 19. For the following values of Gi of x, C for all ICI is an 19, 73 cyclic cos over F19. The code C is cyclic of length 19. For I from 1 to 6, Gi of x, Gi star of x divides x19 minus 1. We have in the condition of theorem of construction. Consequently, orthogonal of C is included in C. P of C is an 114, 102, 3 codes over F19. Therefore, an 114, 93 quantum codes is given by theorem 7. For FQ equal to F41, equal to F41, that is to say the finite field of 41 elements and equal to 60. The factorization of x60 minus 1 is given by magma. For J1 of x equal to J2 equal to J3 equal to J4 of x equal to x4 plus 32x cubed plus 38x cubed plus 23x plus 4, and J5 of x equal to J6 of x equal to x4 plus 16x cubed plus 30x squared plus 8x plus 31. This implies that
So-
they are 60, 56,
So you
3
have
cyclic
only
codes
two more minutes
over
left.
41. So the code is cyclic of length 60. P of C is an 360, 336, 3 code over 41. Thus, an quantum cost is given by theorem 7 of parameters 360, 312, 3. The main object of this work is the construction of quantum error correction codes based on the CSS construction. That is, we look for codes over the rank R which contain their dias, where R equal to FQ plus U of FQ plus VFQ plus U VFQ plus V square FQ plus U FQ plus U V square FQ. In the next article, we can study quantum codes derived from constant cyclic codes over the rank R, and we wish to study also other constant cyclic codes on this rank which don't necessarily contain their dias in order to have other quantum codes which have good parameters. Before finishing, I would like to express my gratitude to those who participated in the organization of this conference. Everyone knows that the work put into making these events happen is enormous, but it shows the love we have for science and research. Once again, I thank the organization for this work, and thank you for your attention.
Thank you, sir. Thank you for your presentation. Any questions?
No questions. Thank you so much.
Thank you.
Anyone? Any questions? Okay. So thank you so much, sir, for your presentation.
Thank you.
That brings us into this presentation, end of our presentation. So, ma'am, now I would like to have your valuable remarks for our participants. I would like the session chairs to give the valuable remarks to all our participants.
Thank you so much. So in my opinion, all the papers were very nice, very good, and very well presented. And the authors were also confident, and they also gave the replies to our questions as well. So I think it was very well, and we wish them all the best for the future endeavors. Thank you so much.
Thank you
And
so
thanks
much,
to
sir.
GR Foundation also for organizing such a nice conference in offline and online, both the modes.
And thank you again for your efforts.
Thank you, thank you.
Thank you so much, sir. Thank you so much for your valuable and kind words. Ma'am, you have any valuable remarks for our participants?
I just want to agree with my co-chair. Thank you so much. It was really very well presented, professional presentations. The topics were really interesting. I must admit, the last presentation did lose me a bit with all the mathematics. But good luck with your research, sir, and all the best for all the other presenters.
Okay. So I would like to sincerely thank all our authors for their wonderful and excellent presentations and their contribution in this session, and all our participants for being a part of this one international conference. I hope this session was informative enough, and we, on behalf of the whole team, thank you for the all support during the 9th version and all the previous 8 versions of the conference. We're happy to have you in the 10th version as well in 2025. All the participants and the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2024. I would like to thank both of our session chairs for chairing the session. A token of appreciation on behalf of the team ICICT 2024 and Global Knowledge Research Foundation and partners to both of our chairs. Thank you so much. Thank you so much for your valuable presence. Now, I would like to request all of you to switch on your camera so that we can have a quick snapshot of our conference.
I have one quick question while we're doing that. Will the videos of our talks be available anywhere?
Yes, sir. We are actually, this whole conference has been recorded, so you'll be getting it.
Mm-hmm. Very good.
On website gallery tab, you will get it.
Thank you. Thanks a lot. Have a good day. Stay safe and take care. Thank you.
Thank you so much. Thank you so much.
Thank you
Bye
very
bye.
much.
Take
Thank
care.
you, sir. Thank
Bye
you.
now.
Thank you so much. Bye-bye.
Goodbye.